Hi, everyone. Welcome to this episode of the Power Hungry Podcast. I'm Robert Bryce. On this podcast, we talk about energy, power, innovation, and politics. And I'm pleased to welcome Björn Peters. He is the co-founder and CFO of a Canadian company, a Canadian nuclear company called Dual Fluid Energy. Björn, welcome to the Power Hungry Podcast.
Thanks for having me. It's a great honor.
I hope you think so when we get done. So you wear many hats, Björn, and I didn't warn you, but guests on this podcast introduce themselves. So I'm talking to you largely because of your activism in Europe and particularly in Germany around nuclear. But if you don't mind, imagine you have about a minute or so to introduce yourself to a group of people who don't know you. Please go ahead, introduce yourself.
Well, I'm a physicist and an energy economist by training. I've come to the energy policy via being an investor at Deutsche Bank for renewable energies mostly, but I found out that that there were lots of issues around the energy transition. So I started getting into the policy space, and since about 10 years, I'm publishing and writing about energy, about the German energy transition, and so that is I'm a political advisor to to those who listen, and
and you need more of those who are going to listen in Germany, no?
It's for my daily living. I'm a consultant to some companies. I help them becoming bankable, and I've gone into the startup scenery more and more. And I was co-founder of Dual Fluid Energy, and that is a company that tries to really reinvent nuclear in a very drastic way, reinvent their business model of nuclear energy. And so I find this even more, I can change more when I'm successful at Dual Fluid Energy than if I'm a politician, I believe.
Good. Okay. Well, we'll get to dual fluid, but since you're German and you're you said you're outside of Frankfurt now. You live outside of Frankfurt. I wanted to get your update on what's happening in Europe. I've written about Europe. I've talked a lot about it. And from where I sit, the European energy crisis only seems like it's getting worse. But then I'm not there. So tell me give us the update on what's happening, how you see what's happening in Germany and more broadly in Europe now around gas supplies, electricity, the future of nuclear, et cetera. Give us a quick update, please.
Yeah, the thing is that this energy crisis started in the first half of 2021, and I believe it is entirely policy made. We were facing very low winds, particularly in Western Europe, and the answer was burning more gas in order to provide a sufficient amount of power. In Brazil, there was a drought, so not enough hydropower. So what did they do? They bought LNG and burned it in their power stations. So this scarcity of gas was building up until mid 2021. And I was actually giving an interview somewhere saying we're seeing an energy crisis here. I couldn't imagine how severe it could get actually. And then came the Russian war, and the scarcity was building up and up. And even in Germany, we didn't order more gas. I don't know why. I think that's a miracle. So usually you think if you consume more gas, you just order more. Putin was saying, well, we delivered exactly what the Germans were ordering, and I have no reason to doubt this. So maybe the wrong people were ordering. So came the shift from 2021 to 2022, and we had about a quadrupling in power, in gas, and of course related in carbon markets.
And quadrupling in prices
between beginning of 2021 and end of 2021.
Right.
Of course.
Yeah.
The prices were quadrupling, and as everyone with a clear mind knows that prices are scarcity signals, and high prices mean high scarcity. So the scarcity was building up nearly a year ago. And then came the Russian invasion of Ukraine and the loss of the pipelines for whatsoever reasons. I mean, we can discuss this separately, but we effectively lost them. And now we are really in the middle of very severe winter. Our gas storage is full. Actually, we acquired gas at insane prices, driving markets up all over the world. But that's good when you have deep pockets. You can do it. And now we have to pray for a mild winter, because if the winter is getting cold, then the gas supplies will not be enough, and we'll have to make tough decisions.
So let me follow up on that, because I testified before the U.S. Senate last fall, pointing out that Europe was already having problems. So how do you respond to the people who are saying about the European energy crisis? And I had a guest on recently say, well, why is Europe in an energy crisis? And he said, Vladimir Putin. Is that true? Can Europe blame all of its problems on Putin?
Absolutely not. I mean, all the reasons that we are in this crisis are policy made. The one was the increasing reliance on weather-related energy forms. And if you depend on the weather, you need to understand what it means. But nobody asked that questions. The right questions about the spatio-temporal behavior of weather and whether it fits to our energy needs. And
let me interrupt you if you don't mind, because I think this is just such a key point. I mean, here's how I view it, Bjorn. To me, it's very simple. If we're facing more extreme weather because of climate change, why in the world would we make our electric grid depend on the weather? Am I seeing this too simply? Am I just, because I'm from Oklahoma and I'm kind of slow, that this was a dumb idea?
Actually, I don't share the premise that extreme weather is getting more frequent, and if so, on a very slow scale. But even the elementary, so what is weather, and how broad are the distributions of possible weathers, we have never bothered to understand. I mean, we are actually lacking some sort of a statistical meteorology that deals with the full distributions of what weather actually is. And then if you take certain weather parameters, such as the wind speed at 100 meters height and the solar irradiation, that is the determinant, those are the determinant factors for a renewable energy system. They might have other specifics. So we know from the Bible that there may be 7 fat years and seven meager years. But we have no clue whether there are 7 years with good wind and 7 years with bad wind, because nobody ever bothered asking the question.
Yeah, that's a great point. That the changes in these weather patterns could be far more sustained than anything we've seen before. And this was one of the I think a great point that you made just a moment ago about that the gas storage in Europe was falling already last year because of low wind speeds, right? And then by February, then when Putin invaded Ukraine, storage was very low, and he had a strategic advantage just in terms of the gas supply. Is that a fair analysis?
Absolutely. So this reliance on gas, I mean, we had it already 20 years ago when we started the fast build-out track of solar and wind energy.
You're speaking about Germany and with the Energiewende here specifically, or broadly in Europe?
But it's not so. So all Europe did similar things. We were just a little bit ahead. So the investment markets for solar and wind energy were particularly good. We paid half of the learning curve of the global solar market in the first years of the century. That is. So we played a more important role, but we have a renewable energy directive in Europe as well, and so this reliance on weather-dependent energies, how I call them, because that's probably the more appropriate term, that has spread all over Europe, and it has become a goal in itself without asking what you really can achieve with it. Initially, we wanted to decarbonize the grid. But whether weather-dependent energies could actually do that job. There were very superficial studies around it, and still, until the very date, in many scientific institutes, you have studies that say, okay, we test we test this and that system for 1 year, and if it works, it's okay. But the trick is that in weather, you need to understand the longest doldrum and the longest period of cloud-covered skies. And this is totally irrespective of climate change. Climate change is then an additional risk factor, because we don't know the state, but we don't know how it evolves and whether it gets better or worse through climate change.
That's a really good. I'm sorry to interrupt again, Bjorn, but that's just a great point, and it's one that I hadn't thought about in the way you couched it. That there wasn't sufficient understanding of, you say, the wind doldrums or the cloud cover and how long those can last. So independent of what the climate may do in the future, there wasn't sufficient understanding of what's happening or what the potential occurrences are now. That's just a great point, and I hadn't thought of that. So yeah, that's great.
We simply are not prepared. We're going away in a blind flight, and we don't know whether our plane will land or where, and or whether it will crash or whatever. And that's one point. And actually, the second very important point of policy implications on this crisis is the defund movement. So starting about 5, 6, 7 years ago at Wall Street, and being popular a little bit everywhere around the globe. So I was working in asset management at the time. And people started pulling out money out of fossil fuel companies, and that is very crucial. In previous times, in a time where gas is missing on the market, some companies upstream companies would have said, okay, let's start drilling more, and we will. And within months, they would have reacted to the high prices and would have made a huge profit out of it. But now they are defunded, and there's not enough money in the sector, so the sector couldn't respond quickly enough. And then I believe in the US you have a few specific topics there, with the Biden administration not granting sufficient land for drilling. So all of this crisis that we are facing is really policy made, and it's not falling from the heavens.
Well, then, so just follow up on that then. Well, so I want to talk about, you've recently published, in September, you published a very good paper called The Global Renaissance of Nuclear Energy. You also have published a paper about the German electricity market and what would happen with nuclear plant if you extended the life of 6 nuclear plants in Germany, and what positive effect that would have in terms of lowering prices. But before we get to those, so give me the prescription then. You've laid out, you've said this is all policy made. This disaster is all due to policy. It's not due to Putin. Putin accelerated it, but the policy decisions were already causing the crisis. So what's needed? What should happen right now? If I made you the energy minister of all of Europe, and you had the decision-making authority, what would you do?
Well, it's very simple, actually. In short term, what you can do when a good is scarce, you produce more of it. And we have still serious plans of shutting down nuclear power plants all over the Europe, coal power plants. I mean, it's not good for our carbon footprint, but these errors were made years ago. So we won't have the option to steer it back, because what is happening, if energy is scarce, people will start burning everything to have heat in their home.
Right.
And for the pollution situation, you can see this already in Warsaw, where air quality has deterred very much. So it's really going badly there. And 40% of Polish people don't know how to get their homes warm at those high prices. We don't have numbers yet for Germany, but it will be very similar, because everything is getting much more expensive in times of an energy crisis. So money will be missing somewhere. And if it's really staying cold in your home because there is in a town because there is no gas supply, guess what people would be doing? They would probably go out and riot and do everything to secure their supplies. I mean, this is really serious.
Well, so I've also seen reports about the forests in Germany being cut down now. People to burn firewood. Is this the case as well? That there's already scarcities of or lack of supply of firewood?
Absolutely. I mean, everybody. I do have a fire oven, and I've bought. So I filled my supplies there so I will get through the winter, but I ordered it relatively early. So of course the supplies are limited, and we will have to see who gets what.
I have to ask you because I saw this comment. In fact, it was just a few days ago, and today's October 17th. It was Angela Merkel, and she was giving a speech in Lisbon just recently. And she was asked about her governments. She was in power for 16 years, during which much of this policy happened. And she said, "You always act in the time you were in." And she said she didn't regret her decisions. And then she said, this is a quote, "From the perspective of that time, it was very rational and understandable to get pipeline gas, including from Russia, that was cheaper from LNG from other parts of the world." And she added it, "Even in the Cold War, Russia was a reliable energy supplier." I mean, there are a lot of people who are involved here, but should she be held accountable for this current crisis that Germany is in?
She and Gerhard Schröder, the previous chancellor, of course, and all parties, essentially all parties that are in the parliament, have played that game. It was more or less, it was not really invented by the socialist green coalition of 1998 to 2005. This started in about 1990. Excuse me. This started around 1990 when the Christian liberal coalition of the 1990s built out or explored the space of solar and wind energy. And at the time, I mean, everybody was happy with it. It was small scale, and it was about getting to scale, and there were lots of thinking around it. And then in 1998, it was the socialists and the green government that introduced an investment scheme for solar and wind energy where you couldn't lose money, or
Right.
nearly. Actually, you could, but
You had to try to lose money.
Sorry. It still depend on the weather, and we had very weak wind years in the middle of the zeros. But that's another story. So essentially, all the governments were acting as if they were just the political arm of the wind and solar lobby. So everything that went into the laws could have written directly by the boardroom of a wind power company, and that is very strange. So I don't even think that that there was open corruption around it. Just everybody believed this was the right thing, so Merkel certainly has to be blamed for the nuclear phase out. There's another story around it. In 2009, Merkel and the Liberals campaigned for and with a program that said we will need nuclear energy much longer than until 2022. Mm-hmm. We can do the phase out only 10 years later, which is, I mean, debatable, but whether we will be ready to build on weather dependent energy sources by 2032. But so they and the initial date set by the Greens and the socialists that used to be 2022. And then so they campaigned, and they made a very thorough study on the conditions of the energy transition in Germany. And the result was, okay, we really need nuclear energy for more time than just to 2022. It won't be enough. You can't speed up wind and solar deployment and storage deployment in a time frame that is sufficient. And then came Fukushima, and suddenly she switched off her brain and just said, "Okay, we have to react here to anxiety," and so. And she was not leading; she was following the trends, like she was actually doing all the time, and just never really led big changes, and was just overwhelmed by what was happening. And therefore everybody takes her in the foreign countries. I've had many conversations that she was considered to be a great leader, but actually I didn't see any example where she really led the pack and said, well, this is what we have to do.
So you're saying that Merkel just she was responding to the political whim of the moment instead of saying, no, we need to take a longer term look at what our energy security is.
Yeah.
Yeah. Well, so let's talk just a minute about your paper that you published. This is I think it was in August that you published it, but you did an analysis. By the way, I have to ask. So I speak no German. Your English is excellent. Did you go to school in England? Why is your English so good?
Well, thank you very much. First place, actually, I had some years at school. I did Cambridge first certificate training. Can recommend this very well.
Okay.
You learn a little bit about grammar. And then I focused totally on French. So sometimes I tried to speak French perfectly well, and I could do it actually for speaking 20 minutes without a single error in it. And then once I came back to science and to my PhD time, and my first job was with McKinsey, and this was always an English-speaking environment, and so I had to get practiced in this. And then I guess your English doesn't get worse when you watch Downton Abbey or something like this. Just a pleasure to watch in the original language, of course, and it's really a pleasure. And my daughters have picked it up very, very well as well. So that's.
And what's your hometown? And your native German? Where are you from in Germany? What's your hometown?
It's a very small village, a little bit north of Ulm, with a tremendous history that goes back for 10,000 of years, literally. Wow. So very close to that. So I grew up in a castle that was on a rock, and only 2-3 kilometers away, or 2 miles, sorry, 2 miles away, they found the oldest music instruments, about 27,000 years old. So this area must have been populated for a very, very long time.
Wow. Okay. But you don't live near Ulm anymore. You're living closer to Frankfurt now. This is a different part of Germany.
I moved for university. I had to move from there.
Sure.
Because it was not so attractive. In a village you have no university, so I picked Mainz, which is a very old Roman time as well, the town.
Sure.
And I met my wife, and so I had a few other stations. So yeah, a few other living places in Denmark and in France and in England and so but in Berlin, but I came back, and I'm living now here since long.
Gotcha. Well, so just I want to hit quickly on. I want to get on the paper you wrote on the global renaissance of nuclear energy, but you also wrote another paper. You've been busy lately on energy prices or electricity prices in Germany, and this paper I translated it from German. The global renaissance paper is in English, but you wrote that the simulation that you did on the German electricity market showed the strong nonlinear effect of maintaining nuclear power plants on the affordability of energy. And then you've already talked about scarcity, and the punchline here is that you said that if to keep the existing or 6 nuclear power plants online would result in a reduction in price, in the wholesale price, of roughly 50%. Have I summarized it pretty well?
That's the case. We have several effects here that all play towards price reduction. So first of all, nuclear energy in Germany, so the old power plants, we don't speak about new power plants, so old power plants that are written off, and they just need to earn money for the fuel and the operations. They operate at about below 2 cents per kilowatt hour. So they're cheap. So,
Yeah.
and we're talking about, so Germany has now 3 nuclear power stations in operations, and another 3 were switched off just last December.
Right.
And 2 of those could be brought back online relatively quickly. So the decommissioning hasn't really started yet. While the 3rd one, or the 6th one, which is in southern Germany, actually just a minute, how the crow flies, or 5 minutes or so from this very village where I grew up, in Gundremmingen. They have started decommissioning work, and it would be possible but difficult to bring it back online. But with 6 nuclear power plants, they produce in total something like 60, 65 terawatt hour per year. And that is about 12% of the entire power market. And the power market is very inelastic, so usually it reacts a lot on demand shifts. So 12% in year average, I mean, that really makes a lot. And what I found out when dealing with the data is that there is a transition from, in the merit order. So first you have all the nuclear power plants, then the lignite power plants, and the hard coal power plants. And then there's a jump that didn't used to be so pronounced towards gas-fired power plants.
Right.
But now in this gas crisis, gas became much more expensive than coal. And the power out of gas.
And the merit order, just to clarify, the merit order is the cost to produce, that they're dispatched based on the cost per watt hour, and how they're dispatched into the market. Is that what you're talking about when you discuss merit order?
In any market with a commodity, you have a certain demand, and the supplier, the most expensive supplier that can deliver into that market, sets the price for everybody else.
Right.
So under the condition that this is a transparent market, but for power markets, that's a very good assumption to take.
Okay.
And in this, so the power plants line up naturally according to their cost, and the more demand there is, the more power plants will have to deliver. And each time you increase demand, you get in a more expensive power plant, and so it builds up. The price builds up. And now, what happens when you arrive at this coal gas switch? In previous times, because there's carbon taxing and coal and gas weren't really expensive, it was not such a big. It was more or less a linear ramp. But nowadays, with 200 euros per megawatt hour in gas, this leads to some 450 euros for the power out of gas power plant. And so the very important question is, how often do you have gas power in the grid, so that it's price determining for the entire market? And with these 8.5 gigawatt in nuclear power, at an average consumption of around 50 to 60 gigawatt. So this brings down the number of hours you are in the gas realm quite significantly. And because gas nowadays is 3 times more expensive than coal power, so it's a huge price shift. And that was the primary effect, and then there are secondary effects. So if we use more nuclear, then we will consume less coal and gas. So those markets are not as much in stress any longer. It's not a huge effect, but again, all those markets are relatively inelastic, so they strongly react on price signals. Although this is not pure science, so it's very difficult to assess. So the 50%, it's a ballpark number, but it's just showing that it's really significant. And then the second effect is that if we use less carbon fossil fuels in the power market, we will need less carbon emission certificates.
Right.
So these markets are relieved as well. And less demand means lower prices.
Well, that's a good summary. I like the way you put that. And you mentioned it before, that this idea, an energy crisis. You wrote this. This is via Google Translate. You said more generally, an energy crisis is characterized by high prices. High prices are scarcity prices, and scarcity can easily be remedied by expanding supply. And what I hear you saying, if I'd feed that back to you, in the electricity market, the price is determined at the margin, right? Relatively small increases is the same in oil and gas and many different commodities. But I'd argue whether electricity is a commodity, but that's a separate discussion. But any marginal increase in supply will have a big impact on price. So
Right.
even though
Not always, but in some hours it does, and then suddenly you fall from 450 to 130 euros or so. Per megawatt hour, and that makes a big difference. And then there's another effect. If you need more power, the power gets more expensive, but you buy more of it. Mm-hmm. So there's a double effect in the average pricing.
Gotcha.
So when it's cheap, you buy less. When it's expensive, you buy more of it.
But your volume purchase at higher prices is bigger, right? Yeah. So that it magnifies that impact on the economy. Well, so then what is this is one of the first questions that I had written here and I didn't get to it until just now. So what is the effect on German industry? I mean, how much of it has closed, has shuttered? I know I wrote recently about Eurometall and the non-ferrous metal producers across Europe, the fertilizer producers across Europe. Heavy industry of all kinds shutting down. What's the situation in Germany now? How severe is this? Because these companies, these industries, what do they call them? The Mittelstand? Is that what their name is? The medium-sized industrial companies. What's their condition now?
Well, the medium-sized industrials in Germany, it's a different definition than worldwide. I believe worldwide you think about companies with 50 employees or so. Here it is 250 to 10,000 employees, and we have thousands of those companies being probably somewhere world market leader in their particular niche, and many of them are getting out of business or moving to countries with better energy economies. So in case you manage to keep energy prices down in the US, Germans in general like the US, so there might be more companies coming over and so weakening our economy and strengthening yours. But that's the price for bad energy policies, I guess.
Well, so what effect has there been any numbers published about how many, as a percentage of your overall industry? I know BASF, your giant, the chemical and industrial giant, they are heavily dependent on natural gas, and they've talked about closing down some of their operations. Do you have any indication about how many companies have shut down? What percentage of German companies are under stress or going bankrupt?
Well, there are the first databases, but I haven't seen any statistics around it. But what I see is that in the newspaper, every day there's news about companies quitting or quitting Germany or quitting the business at all.
Gotcha. A quick station break. I'm glad to be talking to my friend Björn Peters, my new friend. We were introduced by our mutual friend Mark Nelson, who's been on the podcast many times. Björn is the co-founder and CFO of Dual Fluid Energy. You can find them online at dual-fluid.com. Björn is also he's also a co-founder of the Nuclear Pride Coalition. And you can follow him on Twitter at Björn Peters, BJRN Peters 3, BJRN Peters 3 on Twitter. Well, let's turn now, if you don't mind, Björn, to your recent paper. This one just it was published in the last couple of days, and it's something that I've thought about and have talked about a lot. I haven't written much about it. I've written some about it, but the title is The Global Renaissance of Nuclear Energy, and it was published in a paper on kern.de.
No, it is actually the German Journal for Nuclear Economy.
Oh, okay. Got it.
Oh.
So tell me, we've heard this before, and I'm just going to play devil's advocate here, right? But I can cite many examples in the last few weeks of things that are very positive on the nuclear industry front. Tell me, your headline is The Global Renaissance of Nuclear Energy. Is it real? Is this time different than the other times we've heard about this?
Well, since I joined the team of inventors at Dual Fluid 4 years ago, and we started our company last year, in January last year. It got the financing right, and so that was mainly my task, of course, as a CFO. We went to lots of conferences, and me personally as well. So I actually like representing the company and listening to people and learning about the industry, because I'm not a nuclear physicist. So I did physics, but statistical physics stuff, and a PhD in brain sciences, and so I never had much contact with nuclear energy until relatively recently. So I had lots of conversation and listened to many speeches of people from SMR companies mainly. And I realized that what we are doing at Dual Fluid, this innovation in several dimensions, we're not the only ones. So many of the SMR companies are actually pursuing that way. And so together, this could have a very fundamental impact on how people view energy and climate by mid-century. And let me get into this. So the first technical innovation that is really important is about simplicity. So we have to make nuclear reactors much simpler than they are. Ideally, that you don't need a nuclear engineer on site. And this is possible with some designs. Very much, I don't know how far your listeners are into nuclear energy. So there are different types of fuel, solid fuel and liquid fuel. And those with the liquid fuel have a big advantage over those with the solid fuels in some dimensions. So this is designed to simplicity, is very important. Second is temperature. Actually, when you build a power plant that operates at 270 degrees Celsius, that's very nice. You can produce power quite efficiently. But if you have 500, 600, 700, 1,000 degrees, and some of the reactor designs allow for that, you can fuel chemical reactions directly. You can produce synthetic fuels in arbitrary quantities. So we could even stick with our combustion engines, because we simply switch the fuel to something that's environmentally more friendly than fossil fuels. And the third very important impact of this might be, and it's something I have heard a lot among my C-level colleagues from other companies, that they want to do it, but nobody has, I believe, really understood what it means. And that is serious production, bringing industrial manufacturing processes to nuclear energy. And one guy in Atlanta on a conference said, and I really love this phrasing, we usually build airports. We need to learn how to build airplanes. And there's a lot of how does the airline industry develop and build an aircraft, a new aircraft model? So there may be the 777 by Boeing. They first design it, then they pre-license it, then they go to all the airlines and say, how many of those do you order? And if their order book is full, only then they go to then they start building the factory that builds it, which costs 10 billion or so. So it's very substantial, the cost. But the individual aircraft, it's still in the 3 digits million range, so a few hundred millions. But it's actually quite affordable, and it can be built in budget and in time and in budget. It can be delivered if it's not just the 737 MAX. I think there was another issue there.
Right.
But usually these things don't happen, because all the technological issues have been pruned out of the system before it gets to the market. And that's if you take these types of manufacturing processes and apply it to nuclear energy, That means that you get into a production mode of maybe 50 reactors per year per model, and you need the customers for it. We're coming to that point, but it will take only 2-3 years or so to build an entire nuclear power plant. Whereas it's now totally normal to build it to 5 to 15 years, let's say.
Right. So let me interrupt you there, because I think that that's a key point, and it's one that, and I'm looking at your paper now, and you project that today we have about 450 nuclear power stations, and the goal should be to have one with tens of thousands of them by mid-century, so in 30 years or so. But let's talk about that scale up issue, because it's a point that I think is really critical, and it's one that I've made. Well, why are our diesel engines so good? Why are our gasoline engines so good? Well, the automakers build them by the millions per year. I mean, they build millions of them, and so they get incredibly good at improving that design, right? The Otto cycle and diesel cycle engines that have been around for a century, and they're just tweaking them, little things. Not, I say little, but turbocharging and all these other things. But how do we get there, though, Bjorn? I mean, it seems that this is the big challenge, that there's the intersection of the regulatory part with the mechanical and physical parts and the limits on industrial processing. How do we get that? Well, let's address the regulatory part first. And this question, which a woman named Sabrina Johal with General Atomics made in a piece that she published in The Hill last month. That ultimately her point was, we're going to have to settle on 2 or 3 designs, that we can't have 50 different reactor designs. We're going to have a few that we know and that can license. So the questions are, who are going to be then the licensing agencies? Will the Nuclear Regulatory Committee, you're in, Dual Fluid is in Canada, or you're domiciled in Canada, and I understand why, because the regulatory process there may be more friendly. Are there going to be, first, the regulatory part? Is there going to be one regulatory agency internationally that works with, say, the IAEA, that will be the gold standard for certification on SMRs?
Well, actually, I'm not worried about licensing, because licensing will follow, and it's exactly like this. If you have approved an aircraft by the Federal Aviation Authority and by the European counterpart, you can start and land on every airport on that globe. I don't know for China and Russia for sure, but essentially, so all the free world, they follow their approval process. So I think approval process is not really so crucial. Much more important is cost. We need design to cost. We need to provide energy cheaper than coal, oil, and gas. And if this happens, all the rest will fall in place.
Well, that's interesting. I hadn't thought of it. You flipped the question on its head, which I like. So you're saying the regulation will follow the good design. If we have the right design, we have the right industrial machine. If we are right, I wouldn't.
I don't know. So maybe I'm taking this too lightly. Might be, but so far. Nuclear power regulation is in national responsibility,
right?
But still, if you have approved or gone through a licensing process in one country,
right,
now you're building a very similar power plant in another country, the regulation authorities today speak very much with each other and coordinate, and can I have this, and how did you do this and that. So there is lots of collaboration going on, but the picture that I have in mind is the X-ray machine at your dentist. You don't need you don't need a nuclear engineer to operate it.
Right.
Second, you don't need to license it. It comes with a license.
Right.
And once this license is granted, you can sell it everywhere.
Gotcha.
And these discussions are going on. I've heard Rumina Velshi from the CNSC talk about it, and the head of the US licensing body, just missing the name. But so they are very much aware that they need to change their licensing procedures. the right discussions are going on there in this area, I believe.
Okay, so then I'll just read that back to you then. So to be clear, so New Scale Power, the U.S. company, Oregon-based company, in late July, they got design certification from the Nuclear Regulatory Commission for their water-cooled reactor. So your belief is if they can scale up, they'll be able to deploy it because they have the stamp of the NRC then behind it. Is that?
Yeah.
Okay, so to just make a finer point on it, then your view is, and I'm not doubting it, but that is if the company is if they can come up with a better design, right, a one that's passively safe, low cost, say 50 megawatts electric or 50 to 200, which seems to be the sweet spot. If they can get that, if they can start producing, if they can prove that they can do it, they're going to find that market, and the market will then, and the regulatory market will respond with approval that then will allow it to be deployed nationally or internationally. Is that your view?
Absolutely. Now, if you think about a typical SMR with some 200, 300 megawatt in power, it's maybe not even in the big OECD countries where this will start. It might be in today's developing market, and if you're in somewhere in the middle of Nigeria or in Timbuktu or somewhere, you need power. Okay, what's your choice? You can buy an oil-fired power plant, but there's no pipeline. You can buy a coal-fired power plant, but there is probably no rail system. So you could have one full train of coal every day,
sure,
or every week. And so if I go to them and say, well, here's a power plant, it's absolutely foolproof, it works, you can't control it, it controls itself. And by the way, we deliver the fuel and it stays in the reactor for 25 years. And then we take it back and you provide you with the next cartouche of fuel. And by the way, it's cheaper than all other alternatives. Why shouldn't they buy my power plant?
Well, look, you've converted me. I was easy to be converted because I'm familiar with these arguments. Well, then let's talk about dual fluid then just a minute. So what is it's a salt reactor, right? Is this
it has a very unique design. Actually, it's one of the first truly novel reactor designs since 50 years or so. It is building on liquid metal as a fuel, liquid uranium, actually eutecticum together with chromium to bring down the melting point below 750 degrees. It is operating in a relatively complex structure made of high-performance ceramic material, and it's cooled by lead. Lead is not only the most efficient energy or heat conductor. It is very good neutron shielding machine, and so we operate at the fastest neutron spectrum of all designs and the highest temperature of 1000 degrees. And the beauty of having a liquid fuel is actually known since very long time, since the 1950s. It is that the nuclear reaction controls itself. There's only one single parameter that defines the speed of the nuclear reaction, and that is the amount of energy you extract. So the lead pump, the speed of the lead pump defines the reaction, the fission reaction speed, and that's it. So you can't do anything good or wrong. There are no steering wheels, no valves, no steering rods, or so. All of these things you can do without it. So we will bring down costs and make it so simple that you don't need necessarily a very large team of operators.
So if I may interrupt, so you're saying if I stop the flow of the lead, you're pumping lead as the coolant through the system. If you stop the flow of the lead drawing heat out of the reaction, then the reaction stops.
It doesn't stop absolutely. It stays in this nearly zero power is a stable state of the system.
I
So
see.
you can, you always have a little bit of radiation of radioactive heat leaving the system. So there's always a little bit of nuclear fission reaction going on. It's a stable state that can stay there for 10 years, and then you start pumping again, something like that. So that is.
And so the chromium uranium mix then that's where the reactivity occurs, and the lead is the coolant that then acts as the heat transfer agent then between the to move the steam turbines in the powerhouse then.
Yeah, exactly. So there will be definitely an additional heat exchanger,
right?
With probably supercritical carbon dioxide, or we have a few other ideas as well on how to produce power there. And the good thing is if you have 1,000 degrees initially, it doesn't matter whether your cooling basin. So you always need the energy is in the difference of the temperatures, not in the temperature itself.
Right.
So you need a cooling system somehow in order to make power out of it.
Right.
And whether this is 0 degree, 20 degree, or 50 degree actually doesn't make such a big difference when you start at 1,000 degrees. So you could build this in the middle of a desert without water cooling. Just air cooling would be sufficient, not ideal, but it would be good enough.
Because your temperature differential is so large.
Yes, exactly.
And then because you're getting such a high output temperature, then your enthalpic efficient, I'm using the right term here, the enthalpic efficiency of the machine is much higher, right? Because that outlet pressure, the higher the outlet temperature, the more efficient you can produce power from that temperature gradient. Then am I getting my physics right here?
Yeah, absolutely. But the efficiency is the less important the cheaper the initial energy is. But of course it's nice to have it. It's nice to have a high efficiency.
Gotcha. So let's go back to Germany now, because we've covered, I think, both of your papers, the ones that I've been looking at, and also about dual fluid, which, as I mentioned, dual fluid energy is a Canadian company. It's based in Toronto. Is that right?
In Vancouver.
In Vancouver. And you can find more about dual fluid at dual-fluid.com. But let's turn back to Germany for a moment, if you don't mind, Bjorn. And this has been great. It's been really interesting to get your perspective on things. So, but back in Germany, why does the Green Party have so much power? I've been in meetings and people say, "Well, tell me what's happening in Germany." I said, "I can't explain Germany. I don't understand Germany. I don't know. It's not no slam on you, but there's a different psychology in Germany, and why is the hatred in some cases for nuclear has been so strong and so powerful, and that it is embodied, I think, in the Green Party. And Robert Habeck just in the last few days said, "Oh, well, fossil fuels and nuclear got us into this mess, and we can't rely on them in the future." Amidst the crisis, he's saying this, which to me is, I'm saying this, what is wrong with you? Where can you be so dumb? So this is a very long intro into why does the Green Party have so much power, and why has it been so captivating for this German psyche, if I can use that?
People seem to forget that we are not only the country of Karl Benz and Albert Einstein and all those guys, but as well of Samuel Hahnemann, the inventor of homeopathy, and Rudolf Steiner, so the inventor of this anthroposophic bullshit. Ideas. Let's put it neutrally. That's number one. So nature philosophy has been very important. It is the basis. That was in the last decade of the 19th century. So this nature philosophy developed, and three different movements got out of this initial world of thoughts. That's anthroposophy. That is the pathfinder, the scouts, pathfinder. And the Nazism, so they have common roots there, so I'll skip a little bit the mid of the century, but when the Greens were founded, some of these came together again. So there were very much right-wing people founding the Greens. And there, nature philosophy means you want to be irrational. It's even on purpose. So that's one. So that is this. Germany is considered, I believe, quite dangerous because of that. Because we are not acting rational so much, although we do it on an individual scale, but we're easily tricked into believing weird ideas when times are bad in particular. Maybe I can tell a story there. 30 years ago, I went to Auschwitz with, I was a singer, so I studied singing actually as well at university. And with the university choir, we were invited by the Polish government to perform for one concert. And then they said, send us around, and we had to see the Polish cities and understand everything a little bit better. And we went to Auschwitz, and we were guided by a survivor of Auschwitz. And at the very end, he told us, okay, I can see you're all very young people. So nobody has personal guilt for this Holocaust. And you shouldn't feel guilty even. So that should not be your guiding thought. But if you want to do me a favor, please consider one question very thoroughly. And that is, how has this been possible? And in particular, the academic world is tricked into something that is that makes more or less sense, but maybe not. It is maybe even dangerous. And there's lots of psychological studies out that the higher your social reputation, the more easily you are tricked into ideologies that don't make sense at all. And that is really weird. And together with this, or this keeping in mind, we should note that most people, so about 75% of people working in the media sector, have a green background. So they're largely overrepresented in the media because people who are more conservative or more liberal, they're usually good at math and sciences, and they pursue other careers. They don't write. And those who are more better in language and maybe in history or so, they take those journalist jobs. And so there is
this is a bad reflection on my chosen profession, but yes, I think you're absolutely right. The journalists, the media, they don't know the math, they don't do the math, and they don't understand the physics. I mean, that's generally true, particularly in the U.S. We have a scientifically illiterate and innumerate population, and who are our representatives that go into Congress and politics. They're lawyers, they're not engineers, and it's certainly true for the media class. They aren't trained scientific people, and so they repeat these. That's a very interesting point too. The point you made, Bjorn, about the higher your social reputation, the more easily you're tricked, and that this is particularly true. I think this is. I mean, I see it all the time now, particularly in these academic studies that are coming out saying, "Oh, we can do all this huge amounts of renewables, no problem. Renewables will work." And I'm thinking, well, wait a minute. You're missing first principles here. But anyway, I interrupt. But that's a powerful story from Auschwitz. You've thought about that a lot. From the way you told it, that's a very memorable event in your life. Am I reading that right?
Yeah, it is. And I started actually to understand the answer to the question at the beginning of the COVID time. And I'm a man of science. I'm not particularly into speculation. And I saw all sorts of speculations from those ones who were more aggressive about how to limit social life, and those ones who said it doesn't work like that. And so everyone was stating things that they couldn't prove. And people were just believing. And of course, if you don't know, you have to believe. That's essential. But who knows? And it would require very special knowledge to understand whether COVID measures are effective or not. And that's exactly the same in energy markets. energy markets are really bloody complex.
Yes.
So you have to understand the scientific basis, the engineering basis, the economic interest of individual companies acting in such a market, to understand how the market is organized, and then somehow the impacts of certain decisions on national economic level, and then that it's all about psychology as well. So it's really complex, and I don't know many people who really understand or to bother to understanding this complexity and savoring it, and really trying to get out. I mean, Mark Nelson is one of those guys,
Yeah.
but he's one of the exceptionally talented people I've ever met. Anyhow,
Yeah.
so.
Well, and I think you're exactly right too, particularly when it comes to electricity. I think in terms of the market for electricity compared to the physical markets for other, for the true commodities, right? I believe one of the reasons why the electricity business is so hard to understand is that we're misapprehending what it is. That in fact, this is not a commodity. We sell it with in terms that we talk about watt hours and we talk about energy. What we're really important, what we really care about is power, and energy and power are not the same thing. That in fact, it's a network and a service that you can't allow to fail. And so this misapprehension of electricity is part of the problem as well. But I think you're right. In addition, is that incredibly complicated, right? And that by comparison, the oil markets, the natural gas markets, coal markets, I think, I'm not saying they're simple, but they're far simpler than the electricity business. And so when you have people who are non-technical and don't really know the numbers, they don't understand the complexity of the network, the scale of the network. Oh, well, then any solar is good. Any wind is good. Well, hell, the numbers are going up. Therefore, this must be positive. Well, in fact, no, that's not true at all.
And then there are even energy economists who don't know these basic technical facts. There are even engineers
Right.
not knowing these basic technical facts. I mean, it's so ridiculous. And they are famous, and on many German TV shows probably have similar effects. Don't want to mention American names now, but with a few friends from science, I've actually I did this 2 or 3 times that we took together a study coming out of these fake science institutes, and that were quoted very heavily in the press, and try to understand what is their logic and why it was wrong, and why it was deeply fundamentally wrong, and why it didn't obey to scientific standards. And if you, particularly in this energy system modeling, when you try to design a new system building on weather-dependent energies and say, well, okay, it works. But then, for example, every good project requires a professional risk management.
Mm-hmm.
And they don't even have a clue what professional risk management is. I had a Twitter discussion with Mark Z. Jacobson, and he said, well, I'm using 35 years of weather data, I'm fine. But he even didn't understand the question on that this is the basis, and then you start doing statistical analysis on the risk that you're actually occurring. And if you measure the river levels for a long time, then you can derive 50-year, 100-year, 500 years high water mark.
Mm-hmm.
And for example, German nuclear power stations have to withstand the 10,000-year high water mark. So there's a little bit of computation involved, because you can't wait 10,000 years to find out. So you have to extrapolate, building on certain mathematical models. It's not nuclear science. It's much simpler. Civil engineers do it all the time, but in all those professors in energy engineering and system modeling, none of them, I've talked to a few of them, have any clue of what this type of risk management actually is, and therefore their studies are nice to have, but they provide just one possible scenario, but not a class of scenarios, and so it's not robust. And if anything goes wrong on the way, we are left without energy, and this is at very, very high expense.
You know, well, I agree with you, and I've seen these academic studies and those build outs of just staggering amounts of, terawatt scale new wind and solar, right? Which it's not going to happen. I mean, I just look at it and I think, well, this will not happen because it can't happen. The network is just too big. But yet these analyses get published all the time in major media outlets, particularly in the U.S. And I look at them and I just shake my head because I think the reporters the journalists don't have any idea of what the numbers mean or what that will mean in the physical world. And that's the part where I spend a lot of my time. Where are you going to put it? How are you going to connect it? And how are you going to pay for it? Right? Those are the key things. And the first thing continually gets ignored. But it's also one of the questions I wanted to put to you, Bjorn, about the build out of renewables in Germany, because I've been looking at the statistics, and the build out of wind in Germany in particular has slowed dramatically. So can you just speak for a minute? And I know we've been talking for more than an hour and I don't want to continue much longer, but I'll put the question this way. In the renewable sector for both solar and wind, what is the reaction now in rural Germany to these projects? Are they being welcomed? Are they being rejected? And what about high voltage transmission lines? Where is Germany in this regard?
Well, the wind projects and some of the solar projects are just stuffed down the throat of the people, whether they like it or not. They've changed the law so they can actually do it, but they are anyhow not being built because of scarcity of raw material and cost overruns. And so actually I wouldn't know what is going to happen because essentially nothing will be built. And that's even one more reason to keep our nuclear power plants.
So you're saying that the growth of renewables in Germany has slowed dramatically? Am I hearing you correctly? What did that because of local opposition, but also because of the scarcity of materials?
Yeah. So in solar, it's the 90% reliance on China for solar modules, so PV modules. And in wind, it's just the scarcity of materials. Even steel and cement and concrete and so are getting more difficult to source, much more expensive because they're energy intense. And the last wind power manufacturer has left Germany for good for a couple of weeks ago.
Was that Siemens Gamesa? The announcement was that the one? Yeah. And so you're saying it's not necessarily about the land use conflicts, it's more about the issue of materials and cost.
Yeah.
Yeah, interesting. Because I see, and I've reported on this extensively, and not to talk about my work, the renewable rejection database, the number of rural communities rejecting solar here in the U.S. has skyrocketed. As the more solar has been rolling out, in the last year alone, 68 rejections in the United States. This is a big number. And that's not a complete number. I'm still building on that. So I'm glad we've covered a lot of ground here, Bjorn. My guest again is Björn Peters. He's the CFO and co-founder of Dual Fluid Energy. Will the EU hold together, Bjorn? I mean, the European Union is under a lot of stress now, right? And there's the interconnections. There are interconnections on electricity. But if push comes to shove, are the Germans going to export electricity? Are they going to import it? There are a lot of questions about. And I had Alexander Stahel on the podcast recently talking about these things. You may know him. He's a commodities investor out of Switzerland, but very familiar, very savvy on the European electric grid. Will the European Union hold together, or is this going to force the EU apart?
Well, I think we're making everything to make life of our European neighbors more difficult with our energy policy. And so I think it's a little bit in our hands, like it was in the refugee crisis that drove the Great Britain out of the UK, out of the EU. It's very difficult to forecast. So these things are not orderly processes. That happens in a highly non-linear way again.
Yeah.
I wouldn't dare a prediction, but of course, all the stress we're putting on a system makes a break apart or break out of individual countries like Italy or whatever, could be even one of the bigger countries, makes it more likely.
Well, and Alexander made the point that Italy, among all the European countries, that the UK, Italy, Greece, they're in some of facing some of the biggest challenges because they don't have enough power generation capacity. Their electricity prices are very high. The bankruptcies in the UK are now at the highest level since 2009. I mean, these countries are under enormous stress.
Yeah. Italy always has been since their rebuttal of nuclear energy. And then the second public vote in 2012 didn't. So Fukushima didn't help either.
Right.
But as I'm following for some reasons from my previous profession, I'm following the Italian situation since a long time, and they've always had a dramatic deficit of electricity, and that was covered by France and by Germany through import through Switzerland mostly. And that's, of course, in a situation when Germany reduces all its overcapacity, so it can't fuel the neighbors and still expects to other countries to fuel them, that won't work. So we will have, well, in the COVID crisis, for example, we saw that the borders were suddenly shut down, so you couldn't cross a border. And this is against all European treaties.
Right.
And if we don't continue to provide or to be a good neighbor to our power neighbors, then we risk that they shut down the power grids. And that's actually the biggest machine that man has ever built. So the ENTSO-E grid, it's a huge grid from the Atlantic to the Ural, and from North Cap to the Mediterranean Sea. If we don't play our role there will be lots of difficult situations there where I wouldn't dare to predict anything. Everything can happen. And that is something that is really disturbing me. I mean, in my heart, with my history and my family, and so of course I feel even more European than German. So of course Germany plays a very big role in my education and the books I read. But of course I read some Swedish, English, French, Italian books and everything. So and I'm performing the composers of Spain and of France, and so of course it's a European culture. But if we don't learn that this type of energy policy that we're doing or imposing on our neighbors very high prices, so they pay for our nuclear phase out, for example, for billions. So if we reduce the availability of power and probably with a bad impact on the carbon markets, we make the life for everybody in Europe more difficult, not only for us. So they are paying for our errors in energy policy making. And I've heard lots of voices recently. A Swedish Green told one reporter, and it went all over the media here, that if Germany doesn't play its solidaric role, he would recommend to his Swedish government to shut down the power line between Sweden and Germany.
Wow.
And Sweden is self-sufficient, more or less. So it's rare that they really need additional power. It happens, but not that often. But they would do probably better right now without this undersea cable.
Without the interconnection. You said you perform these composers. You're still singing, or you perform musical instrument as well?
No, actually, I learned a little bit the guitar and the violin, but I completely during university time I said one is enough, and I did an opera singer's training. And now and again, so 2-3 times a year, I can't find more time.
Gotcha. Well, good for you. One last thought, and just maybe your reaction on it, Bjorn, but as I've thought about, I've been in the Indian Point nuclear plant in New York before it closed down, and I've been in other power stations and coal plants and so on. And as I've thought about the electric grid as a thing, right, about this network, this incredibly important network, that I think about, well, what do I want behind that? Do I want a big honking sturdy nuclear plant that's going to be there for decades, or do I want to trust the wind and the sun? And I it's just like, I keep thinking about this idea of the engine itself, right? Because it is an engine, right? It's a heat engine that is driving society and creating electrons and this power network that, to me, is I just come back because I used to work on cars and like car engines, and this is the thing of the engine itself that if we're going to power our society, which are we going to choose? And I mean, obviously I'm pro-nuclear, but it just seems to me this is a very obvious answer. You don't want it to be relying on these propellers and on the dilute nature of the sun, but it's just my observation. Have you thought about that at all, just in terms of the machine, the engine itself?
Yeah, actually, that's very fundamental, and I'm happy that you bring it up, because people have forgotten that energy is the single most important driver for civilization. When we started taming the fire 1,000,000 years ago or so, we started probably talking and singing as well, and the culture evolved with it. 10,000 years, when we started taming wild animals and making use of them, we got a new energy source, and we evolved enormously in numbers from 2.5 million to about 250 million by the Roman times, and about 1 billion people until the industrial age. So around 1800, we were 1 billion people. And with this new source of energy coming from fossil fuels and its optimization over these 200 years now, we have doubled our life expectancy. We're much more wealthy. We have totally reduced analphabetism. And so in every societal dimension, this has been beneficial. And and we are now living through a crisis of energy and of energy availability, because the fossil fuels have been nearly totally optimized in its usage, and there's a dead end, and we have to stop somehow using fossil fuels anyhow, because they're getting more scarce maybe, or the carbon dioxide concerns. So what's the next big thing? And it has to be something. And if you think, so this environmental energies we have been using for 10,000 years, the fossil fuels for 200 years, and nature doesn't have anything else but nuclear energy, and be it fission or fusion. So it's very fundamental that we need to optimize the usage of nuclear energy, and this is exactly what's happening in the laboratories of all those startup firms, including dual fluid, but definitely not alone. And we will optimize the usage in the 2030s. We will all collectively bring it to market in a very efficient way, and by 2040, I believe nobody will have to buy a coal-fired power plant, because there are much better alternatives out there. So this is the core. Energy is the core, and it has to operate smoothly. It has to provide the energy when and where we need it, and that's the big failure of solar and wind energy. These energies have to be refined at very high cost and at very high energy investment in order to be used when and where we need it.
I like that. I like the way you put it. But you said energy. You said it is the core, and I wanted you to say energy is the core of society, or just the core. It's the core of who we are as people, right? I mean, it's even more fundamental than that. Yeah. So last two things, Bjorn, and I appreciate your patience. We've been talking now for more than an hour. So I asked these two last questions of all my guests. So what are you reading? You're obviously a man of letters. You speak several languages. I barely speak English. What are you reading? What books are on your bookshelf or on your top of your list these days?
Actually, I just bought but haven't started this book about that's from Alex Epstein.
Alex Epstein, Fossil Future. Yep.
About about fossil fuels, and I think we have to be simply grateful with fossil fuels. But otherwise, I have been in contact with a science comedian lately, and he sent me his newest book about energy and climate policies. It's very well written. I have to write a Twitter thread in to say thank you, and because it's really good, and it some of the thoughts on psychology he came up with. So,
And you said a science comedian? Did you say?
Yes, he's a PhD in physics who turned to be a comedian, and he makes fun. His slogan is "Make science great again."
And he's a German
really
guy.
fun.
Where is he from?
Vince Ebert. He's a German, but actually he lived for some time in I believe New York or so, and he that was his early parts as a comedian. I will send you a YouTube link. He's really funny in English, and a German being funny in English, that doesn't happen very often. I'm pretty sure you will really like it.
Oh, that's great.
And then the third book, and that is it's too thick, so I don't have it when I travel. It's too heavy. But that's actually a biography of Charles the Great, living in around 800. So the first emperor of the German of the European Empire, let's say.
Okay.
Manor Frank.
All right. Yeah, I'm not familiar with Charles the Great. So last question, Bjorn, what gives you hope? We've talked about a lot of things that are fairly sobering today. What gives you hope?
Innovation. I see so much innovation going around, so I'm very optimistic, and I'm pretty sure around mid-century, nobody will talk about climate change because it's solved.
Well, that is a beautiful thing. I'm glad to hear that. That's a great way to end, or a great spot to end. My guest has been Björn Peters. He's the German-based CFO and co-founder of Dual Fluid Energy, which is a Canadian company. You can find more about them at dual-fluid.com. Björn is on Twitter. He's active on Twitter at BJRNPeters. That's a BJRNPeters3 on Twitter. Björn, thanks a million for being on the Power Hungry podcast. Great fun talking to you.
Yeah, it was great fun indeed.
Okay.
Thank you.
And thanks to all of you in podcast land for tuning into this episode of the Power Hungry podcast. Until next time, see ya.